Surface chemistry. In this chapter, you will be studying about adsorption, catalysis and colloids. So what is meant by surface chemistry? Surface chemistry deals with the study of processes or phenomena that occur at the surfaces or interfaces. It can be the solid gas, liquid, solid liquid or liquid gas interfaces. Adsorption is one of the surface phenomenon which you will be studying in this chapter. You are quite familiar with the process absorption. For example, if few drops of water is put over sponge, you know that water will go into the bulk of the sponge. It is not that water will remain only on the surface of the sponge. Since water gets into the bulk of the sponge, we say that water gets absorbed by the sponge. But in the case of adsorption, the molecules will get accumulated only on the surface. It will not go into the bulk. So adsorption is a surface phenomenon. So how can you define adsorption? It can be defined as the accumulation of molecular species at the surface rather than in the bulk of a solid or a liquid. The species or the substance that gets accumulated on the surface can be called as adsorbate, and the material on the surface of which adsorption takes place can be called as the adsorbent. So these are the two terms associated with adsorption. One is adsorbate, the substance which gets adsorbed, and the other is adsorbent, the material on the surface of which adsorption takes place. This figure helps you to distinguish between adsorbent and adsorbate. The adsorbate gets adsorbed on the black adsorbent. You should know what is meant by desorption. Now from the figure it is clear that desorption is just the opposite of adsorption. So desorption can be defined as the removal of the adsorbed substance from the surface of an adsorbent. What is meant by the term sorption? It is a phenomenon in which both adsorption and absorption occurs simultaneously. For example, consider a white chalk dipped in blue ink. After dipping the white chalk in blue ink, take it out and observe the surface of the chalk. You will find that it has turned blue. The surface has turned blue. It is because the blue dye component has been adsorbed only on the surface of the chalk. So here adsorption of the dye component has taken place. Next, take the chalk and break it into two pieces. Inside the chalk you will find that it is not blue but it has become wet. Why it has become wet? It is because water is being absorbed by chalk. So this is an example where you find both absorption and adsorption has taken place. The dye component has been adsorbed and water has been absorbed by the chalk. So here sorption has taken place. Before explaining the mechanism of adsorption, I'll give you two examples of adsorption. Consider oxygen taken in a closed vessel containing powdered charcoal. The pressure of the gas is found to decrease. This is because oxygen gets adsorbed on the surface of the charcoal. Here oxygen is the adsorbate and charcoal is the adsorbent. Another example of adsorption, where adsorption takes place, is that air contains moisture in it. This moisture present in the air can be removed with the help of silica gel. Silica gel is the adsorbent and moisture is the adsorbate. Now let us see the mechanism of adsorption. Consider the figure given. The surface of adsorbent is shown, and on the surface you can find two adsorbent molecules. In the bulk or the interior, one adsorbent molecule is given. Now consider the adsorbent molecule which is in the interior or in the bulk. If the adsorbent molecule is in the interior, that molecule of adsorbent will be well surrounded by other adsorbent molecules on all its sides, so that there will not be any net force acting on such an adsorbent molecule which is in the bulk or which is in the interior. That is, there is no net force acting on an adsorbent molecule if it is in the interior. But when the adsorbent molecule is at the surface, see the figure, such an adsorbent molecule, if it is at the surface, will not be surrounded by atoms or molecules of its kind on all sides. So such an adsorbent molecule on the surface will possess some unbalanced attractive forces. These residual forces are responsible for attracting the adsorbate particles. When the gas molecules gets adsorbed on the surface of the adsorbent, there will be a decrease of residual forces. That means the surface energy will decrease. Surface energy decreases means the residual forces decreases. So where does that energy go? That energy will be appearing as heat. So during absorption, energy will be released. Since energy is released, adsorption can be considered as an exothermic process. Now, you know that for an exothermic reaction, delta H is negative. Delta H means it is enthalpy of adsorption. Since during adsorption, heat energy is released, delta H is negative. Now consider Gibbs-Helmholtz equation. You know that according to Gibbs-Helmholtz equation, delta G is equal to delta H minus T into delta S. The sign associated with delta H is negative. As we have discussed just now, we know that adsorption is an exothermic process, so delta H will be negative. Now we have to consider the sign associated with delta S, the change in entropy. Now when the gas molecules gets adsorbed on the surface of an adsorbent, the gas molecules move from a disordered state to a more ordered state. That means there is a decrease in entropy. So the sign associated with delta S will be negative. Now for an adsorption process to be spontaneous, according to Gibbs-Helmholtz equation, you know that delta G should be negative. Now when delta H is negative and when delta H is negative, delta G will be negative. Delta G negative means adsorption process will be spontaneous. Now as adsorption takes place, delta H will become less and less negative, and finally it will become equal to T into delta S. When delta H becomes equal to T into delta S, delta G will become 0, and when delta G becomes 0, adsorption reaches equilibrium stage. Types of adsorption. There are two types of adsorption. One is physical adsorption and the other is chemical adsorption. Physical adsorption is known as physisorption and chemical adsorption is known as chemisorption. How can you define physical adsorption? From the term physical, we come to know that some physical forces are formed between the adsorbent and the adsorbate. It is actually the weak van der Waals forces which are involved in physical adsorption. Now coming to chemical adsorption, chemical bonds are formed between the adsorbent and the adsorbate. Let us find out the differences between physisorption and chemisorption. First point, physisorption is accompanied by low heat of adsorption, whereas chemisorption is accompanied by high heat of adsorption. That means in physisorption, delta H value will be low, whereas the delta H value will be high for chemisorption. But in both the cases, since it is adsorption, delta H will be negative. Both the values will be associated with a negative sign, but the value will be low for physical adsorption and it will be high for chemical adsorption. Now what type of forces are involved? In physical adsorption, it is van der Waals forces, whereas in chemical adsorption, chemical bonds are formed. What is the effect of temperature? In the case of physical adsorption, it takes place at low temperature, whereas chemisorption takes place at high temperature. Why physisorption takes place at low temperature or low temperature favors physisorption? This is because, see, physical adsorption is an exothermic process. So heat energy will be released. Now, according to Le-Chatelier's principle, when the temperature is low, that means when the temperature is decreased, the system will try to increase the temperature. It can increase the temperature by favoring the forward reaction. So that is why we say that low temperature is favorable for physical adsorption. Whereas in chemical adsorption, it is like a chemical process. And you know that as the temperature is increased in a chemical reaction, the speed will also increase. So high temperature is favorable for chemical adsorption. Coming to the reversibility of the process, physical adsorption is reversible, whereas chemical adsorption is irreversible. Now coming to the nature of the adsorbate. In the case of physical adsorption, it depends on the nature of the gas adsorbed, and it is found that easily liquefiable gases are readily adsorbed. Chemisorption, in that also it depends on the nature of the gas adsorbed. Physisorption is not specific, whereas chemisorption is highly specific. Why physical adsorption is not specific? It is because only van der Waals forces are involved in physical adsorption. Since chemical bonds are formed between the adsorbent and the adsorbate, chemical adsorption is found to be highly specific. Physical adsorption leads to multimolecular layers, whereas chemisorption involves only monomolecular layer or a unimolecular layer is formed. In the case of physical adsorption, no appreciable activation energy is required, whereas in chemical adsorption, activation energy is required. So these are the differences between physical and chemical adsorption. In the figure, you will find charcoal given in two different forms as powdered charcoal and lumps of charcoal. Which form of charcoal do you think will act as a good adsorbent? It actually depends on the surface area. If charcoal is in the powdered form, it will be having a greater surface area. That means if surface area is greater, the rate of adsorption will also be greater. Therefore, powdered charcoal is a better adsorbent and it should be preferred. What is meant by an adsorption isotherm? You are familiar with the term isothermal. Isothermal means constant temperature. So adsorption isotherm means adsorption studied at constant temperature. What is an adsorption isotherm? It is a curve which is obtained graphically by taking pressure along the x-axis and the amount of the gas adsorbed by the adsorbent, that is x by m, along the y-axis at constant temperature. The curve thus obtained is known as or named as adsorption isotherm. Freundlich gave a relationship between the amount of the gas adsorbed by unit mass of the adsorbent and pressure at a particular temperature. This is expressed as x by m is equal to k into p raised to 1 by n. This expression is known as Freundlich adsorption isotherm. In this figure, you will find three different adsorption isotherms studied at three different temperatures, one at 273 Kelvin, another at 244 Kelvin, and the third one at 195 Kelvin. See the variation in the amount of the gas adsorbed by the adsorbent with pressure is studied at a constant temperature of 273 Kelvin. Similarly, the next variation is studied at a constant temperature of 244 Kelvin and the third one is being studied at a constant temperature of 195 Kelvin. Each curve shows a variation in the amount of the gas adsorbed with pressure at constant temperature. Consider Freundlich adsorption isotherm. The expression is x by m is equal to kp raised to 1 by n. Now take log on both sides of this equation. Then it becomes log x by m is equal to log k plus 1 by n log p. This equation is now of the form y is equal to mx plus c. And you know that this equation represents a straight line. So if we plot a graph taking log x by m along the y-axis and log p along the x-axis, we will get a straight line with a slope equal to 1 by n. And the slope will be positive. The intercept gives you log k.